All right, one way that we can solve systems of equations is by graphing them. What is a system of equations? Well, basically that's when we have two or more equations that have two or more variables. At this level of math, we're pretty much dealing with two equations and two variables. And in higher levels, you may see three or four, but there's different, more powerful techniques for dealing with those. What we're looking for is an x and a y that make both of the equations true at the same time. The same x and y work for the first equation that work for the second equation. How do we find those? Well, by graphing, what we're doing is the equation, hopefully if it's written in a standard form, we can just graph it. And what we're looking for then is a point that belongs to both lines on the graph, and that's where the lines intersect. So let's take an example here. We've got a system 10x plus 3y equals 60, and x plus y equals 13. So to graph the first one, the 10x plus 3y equals 60, first we're going to find the intercept. So we let y equal 0 over here on the left. We get 10x equals 60, divide by 10, we get x equals 6. For letting x equal 0, we end up with 3y equals 60, divide by 3, we get y equals 20. So we're going to plot 6 on the x-axis and 20 on the y-axis. We connect those with a nice straight line. Now we've got to do the same thing for the second equation in our system. So that's x plus y equals 13. Well, that's really easy. If x is 0, y is 13, and if y is 0, x is 13. So we're going to plot 13 on both the x and the y-axis. That's the orange points. We connect those. We've got a straight line. So what we're looking for then is there a point where these lines intersect? And yeah, it's right there, and it looks like it's over 3 and up 10. So the solution could be 3 comma 10, but let's check that by plugging those numbers back in. We put 3 in for x and 10 in for y in the first equation. We get 10 times 3 and 3 times 10, 30 plus 30, that's 60, that checks. 3 plus 10 equals 13, yeah, that checks. So yes, 3 comma 10 is the solution to this particular system of equations. Let's take a look at a second example. 10x plus 2y equals 15 and 3x plus 5y equals 10. Let's graph the first one first. So we let y equal 0. We get 10x equals 15, and so x equals 1.5. It's not a whole number. That might be an issue later. We let x equal 0. We've got 2y equals 15, and y is 7.5. Now, depending on how we set up our graph, that may or may not be easy to do. In this case, if you look, we've got 4 squares between the bold lines, and that's 2, so every square is half a unit on this graph, so that actually is not going to be too hard to graph. So we've got 1.5 is going to be 3 squares over, 7.5 is just going to be one line under the 8. Connect those with a straight line. Now, plugging in the zeros and finding the intercepts for the second one is a little bit trickier. We end up with x is 3.3 repeating, 3 and a third. Y equals 2 is not bad, but graphing that 3 and a third, well, if you're doing it on a computer, it's pretty easy. But when you're doing this on paper, it can be really hard to graph the exact point accurately if it's a decimal. We go ahead and graph that, and now you look and say, well, where do they intersect? Well, they don't intersect right on the lines of our graph. That makes it a little bit tougher to tell where they intersect. If we zoom in a little bit more, which again is a luxury we have on a computer but not so much on paper, it looks like, well, if each of those squares now is a quarter unit, it looks like about 1 and a quarter over, about 1 and a quarter up. So maybe 1.25 for x and for y. Again, we're kind of estimating here. It's hard to tell exactly, but we're going to have to plug those in to find out for sure. So we go ahead and put 1.25 in for x and for y. It turns out it does check out, and that is the solution for this system of equation. But it does reveal one of the drawbacks of the systems of equations, which we'll touch on in a moment. This graph here is from our Euler problem. And we had this graph, and we're kind of looking and saying, well, where do those cross? Because that's going to be an important point later. Well, if every line is 10, 2 lines past the 100 looks like about 120 on the x-axis and about 40 on the y-axis. But is that really the exact solution, or is it somewhere in there, maybe 121 and 38.5? It's really hard to tell from the graph. So, solving by graphing can be easy if all of the numbers come out to be integers, no fractions, no decimals. Not just the intercepts where we graphed to get the line, but also where the lines intersect. If we have decimals or fractions show up at all, this can be a very tricky way to go because it's not obvious where those lines intersect, and it can be really hard to get the exact line when you're trying to graph a decimal on graph paper. So a systems of equations by graphing, it's good for estimating the solution, but it's not good for obtaining an exact solution. To do that, we're going to have to use more powerful techniques using algebra, either by the addition method, substitution method, elimination method, and we'll be looking at some of those in the next videos.